Hello everyone, welcome to another episode of the Future Materials Encounters. Today I'm very excited. I'm here at the Jan van Eyck Academy in Maastricht together with Kate Scardifield and Jessie French. They are both visiting Europe in this moment from Australia, from very far away, and their practice is quite entangled with many different realities and spheres. So the best way I think to introduce them is actually giving them the space and the space to their voices to introduce themselves and their materials. So perhaps we can start with Jessie, and then Kate, can you please share a bit more who you are, as well as what are the materials you're engaging with, especially if you can give us also like some tangibility for the listeners who cannot see these materials yet.
Absolutely. So I'm an artist and designer, and my practice really started as an artistic practice, looking at, I guess, in response to the overwhelming issues we have with petrochemical plastics and the impacts they're having on the ecosystems, on our world. And so I started off thinking about speculative artistic project, looking at what a post-petrochemical world could look like, or a world without as many petrochemicals around us. And so I started working with algae as a polymer because the heart of petrochemicals is a fossil fuel, and the fossils are of microalgae. So it was all linked with algae. And
so what do you, if you don't mind me interrupting, what do you mean that fossils are microalgae?
Yeah, so you've probably heard this term of fossil fuels. And so that is because over millions of years, the microalgae is compressed under heat and pressure, and it makes petroleum oil, which is extracted and then processed into what we have as petrochemical plastics that are all around us. And so I really took this as the leaping off point to start these material explorations for how we could be using a more renewable source of algae. And the result of that was it was a successful material, and so I felt that I had a responsibility to really walk the walk of my artistic practice, and so I started Other Matter, which is a design studio that looks to apply the knowledge and skills that I have in working with these materials into real-world solutions.
How can we imagine or visualize the materials you work with?
Yeah, so it is one of the things that Other Matter has really just been working on and just launched is Other Matter decals, which are replacement for what are sometimes called window clings or kind of stickers that go on the wall or the window. And they really started from my artistic practice when I was making exhibitions. And a lot of my work is also around researching the impacts of different petrochemicals, because when we're talking about petrochemical plastics, we're talking about hundreds and thousands of materials. But one of them, which when you have an exhibition, you usually have some kind of wall text that is cut out, thin self-adhesive film, and it's made of PVC. And PVC is a particularly toxic plastic. So it is toxic from, not only is it then, it's extracted in this mining process that's environmentally destructive, then where it's produced, it's creating really some serious health impacts on the communities and ecosystems that surround it. In America, it's colloquially called, the place is called Cancer Alley because everyone that lives there has these higher cancer rates. So by the time you have this material in your exhibition, you've shortened the lifespan of a whole community of people. And if something's affecting humans, it's usually affecting other mammals and other things as well. And then when it's in there, the additives that are added to that plastic to make it soft and pliable and into this small film are a group of chemicals called phthalates. And we're starting to read more about phthalates in the news at the moment because their health impacts are becoming more well known. But they off-gas and they're absorbed through our skin and they impact our endocrine system, which is our reproductive system. And they're having really well supported by science kind of impacts on human reproductive ability. And again, this is not going to be only impacting humans, it's going to be impacting other species as well. It can't be recycled. So it's either incinerated, put into landfill, or mismanaged and ending up in the oceans. And then as it degrades, it breaks down into monomers, of which one of them is chloride, which is a really, really toxic carcinogen. So this material is not very good. And I could not comfortably have it as the medium to explain my whole artistic practice in my exhibitions. So I started to look for an alternative, and so I made my own. Yeah.
Wow, impressive.
So the material kind of looks and feels very much like it's, you can walk past it and not realize it's not a decal and not a PVC decal. It looks like that. It feels like that. In my artistic work, I sometimes mold with the material. So it looks almost like a resin. It's a little bit more flexible. But yeah, that's what it looks like.
And it's the same material you use also in your artistic work?
Yes, similar method, slightly different method for the decals, but yeah.
Yeah, of course. Amazing. Kate.
Hello.
Welcome.
Thank you. It's wonderful to be here. I give a bit of an introduction to myself. My name is Kate Scardifield. I'm an artist. I have a background and training in textiles, and I make work across sculpture and installation, video. I'm also an associate professor in the Faculty of Design, Architecture and Building at the University of Technology in Sydney. So a lot of my work is about kind of bringing together different forms of research and creative practice into investigations into materials and material systems. So specifically, I've always kind of had an affinity, and I have gravitated towards materials in states of transformation. So when they're on the sort of precipice of becoming something else. At UTS, I'm the co-director of the Material Ecologies Design Lab, which is a creative practice and research lab that brings together different design disciplines and connects them with science, with engineering, with business, to think through kind of the way in which our material futures are very much embedded and connected to material thinking and material cultures. So we're really interested in looking at materials not just through their physical and their mechanical properties, but also their social lives and their politic. We've got a number of, material investigations underway in the lab into seaweeds and algae, oyster shells, spent brewer's grain from the beer brewing industry, and recycled glass fines are some. And the sort of material investigations I'm very involved in and attached with is seaweeds and algae. So a lot of my work over the last couple of years has been done in collaboration with other designers, but also with scientists, with algal biotechnicians and polymer chemists. And we've been looking at applications for seaweeds and algae in and across architecture and design.
And if we were to imagine or to visualize the material, like this seaweed and oyster material you're developing, can you just give us a hint or an image?
Imagine a brick, a really heavy, solid, strong brick that has a kind of rough, sort of concrete, masonry-like texture to it, but it has a kind of slightly salty or briny smell to it. So it's got a little bit of fragrance of the sea, maybe. It is a brick that changes colour and that weathers when it's exposed to sunlight. Goes from a kind of bright, great, deep green through to a light white or a kind of madder-like brown, depending on the species of seaweed and depending on the particle size of aggregate and oyster shell that's been composited and mixed with that material. So, yeah, that's kind of what it looks like, smells like, feels like.
Beautiful. So we have spoken about, you're both working with algae, microalgae, so marine materials. And for us, like at Future Materials and in the Future Materials Bank, materials are also ways to interpret, to relate it to landscapes. And I know that both of you in your practices, you relate it. through your material practices, you relate it to specific ecologies. And you mentioned, for instance, the microalgae, how they are actually now perhaps hinting the way to a sustainable future, but at the same time also very much entangled, and I'm looking at you, Jessie, very much entangled with fossil fuels, which is interesting to think about this microecology in relation to time. But yeah, I know you have looked also into the ecology of some of these algae quite deeply during a residency in Morocco specifically. Do you want to share more about what you have found?
Yeah, so it was really at the beginning of this material practice. I was doing some research and kind of appeared, because the polymer I use is agar. So it's really commonly used in laboratories as the growth medium in the bottom of every petri dish in every lab in all of the world. And it forms like a gel. And that gel is actually a kind of cross-linking of molecules, and then that really is a polymer. And when I was starting to experiment with this material, I was researching it, and I found some reports in scientific literature about overharvesting in Morocco. And Morocco is where most of the world's agar comes from, and it's also coincidentally where I had already applied to do a residency. And so I found this out, and I was like, oh no, okay, I don't think I can continue using this material if this is really how it's being harvested. So I found out that I got the residency at La Pause, and I kind of changed my research proposal for them. I was like, I'm going to really do research into the supply chain. And another really amazing coincidence is that in Africa, there's only one processing plant. So it's one processing plant that processes more than half the world's agar. And so all of the kind of, supply chains were leading to this centralized place, which made my supply chain research quite neat. And it also was interesting because when you think about competition and, the structure of businesses, usually having a monopoly is usually kind of a negative thing because there's no competition. But in this situation, it really meant that the company had this huge investment in making sure that their supply chains were sustainable, because if they were over-harvested to the point of not being able to produce product anymore, they lose their business. So what I found out was that in 2014, the shortages were as a result of this actual company bringing in very strict controls. They worked with the government. They're a company called Exam. They're a third-generation family-owned business run by marine biologists, and they realized that there was more product coming in than usual, and they were concerned about this. So they really teamed up with independent harvesters, independent marine biologists, and lobbied the government to bring in these very strict controls. So I wasn't expecting to get to Morocco and have this really, really stringent sustainability practice, but it was. And so I continued using the material.
Wow, it's probably one of the rare cases in which the markets encounters ecological or environmental concerns or models of ethical monopoly, perhaps. It's quite a very interesting research field. Kate, you're working, we know that the coral reef and ocean is one of those ecosystems very much endangered by so many different phenomena connected not only to climate change in terms of raising temperature, but also acidification, lack of oxygen. And apparently algae are these superpower entities or organisms that could help repairing these. How did you relate to these? How did you encounter these?
Yeah, look, maybe I'll talk a little bit about macroalgae. So they're the bigger ones that you can see. There's seaweeds that you see kind of washed up on the beach after a big storm, or the kind of bright green frilly algae that grow at stormwater drains or pipe openings and that kind of thing. Australia is has a really unique kind of southern Australian coastline. It's one of the most diverse places in the world for species of macroalgae and seaweeds. That being said, I think it was something I've learned over the last few years working with ecologists and scientists, is we need to be really careful about how we kind of manage our coastal ecologies. And so when we're thinking about the possibilities of seaweed and seaweed-based materials, particularly if we're thinking about applications at scale as they relate to architecture or building or construction, that requires a huge amount of biomass, a huge volume of seaweed. And so what we don't want to be doing and what we can't be doing is stripping our intertidal zone of that seaweed, because it does a really important job. It's part of a really important ecology and ecosystem where the land is meeting the ocean. A lot of the seaweed that I have been working with is a residual seaweed waste stream. So it's actually seaweeds that are being grown inland and at scale to remediate wastewater. So it's a kind of growing biotechnology that is very much kind of tapping into seaweeds' power to draw down and capture CO2, to feed on nitrogen and phosphorus and heavy metals, and then to expel oxygen. So it is a renewable and regenerative source of biomass that's attached largely to primary industries, so inland aquaculture and agricultural systems. And it's also part of a biorefinery framework. So it's...
What is biorefinery?
Biorefinery is a good question. It is where you've got a kind of system in place where the seaweed is kind of doing multiple things, and you're kind of... for example, it starts by cleaning wastewater and remediating wastewater, and it grows really rapidly in those conditions. So it needs a lot of sunlight, needs a lot of those phosphorus, heavy metals, nitrogen, and then it gets harvested and pressed, and a kind of liquid fertilizer gets extracted, or other value-added molecules get extracted. And then you're kind of left with the sort of pulpy residual material, which, can be put out onto pasture or onto a paddock, and it can compost. But what happens when it does that is it lets all that CO2 capture back into the atmosphere. So the idea and the projects that I've been working on with my other designers and scientific collaborators in the Material Ecologies Design Lab and with the Climate Change Cluster at UTS is about thinking how we can sink and store that carbon, and how we can embed that CO2 into building materials and products and put those into architectural structures and buildings. The science, I think, is really clear. We need to be drawing down carbon from the atmosphere, and we need to put that carbon into something and put that something away for a long period of time.
So the building industry, from becoming one of the biggest polluters of the world, could become like part of a potential solution.
Yeah, potentially, yes.
Yeah. I think implicitly, like now that we're talking about ecologies, we're indirectly, but perhaps not so indirectly, talking also about the opportunities and challenging of scaling up design project, which is a big question behind many of the projects that we have on the Future Materials Bank, for instance, because we're experimenting with all these exciting, potential, non-toxic and ecologically conscious materials. But at the same time, something that we say very often is that it's not about a linear transition in which we substitute fossil-based plastics with bioplastics, so-called bioplastic, but it's about changing the equation, because also thinking about algae, and correct me if I'm wrong here, but if we would have monocultures of algae in the ocean, this would disrupt similarly like the ecologies of the ocean. And so you're engaging both in terms of how to protect these ecologies with agar-agar in Morocco, and I'm sure like beyond that, and also how algae actually could, thriving on all these pollutants in the water. So have you thought about how would be like the scaling up? What are the opportunities, but also the challenges of scaling up projects like yours? And we start with Jessie, perhaps?
Yeah, it's something that I'm looking at the moment, definitely with the decals. So I guess they're a solution that is really needed. There's no other decal option. There is a non-PVC version, but it's still petrochemical. And they're also like, they can't be recycled. They have an adhesive put on them usually that is a really heavy adhesive. If you've ever had to deinstall them off windows, you will know that they leave a really intense residue. Those adhesives often have like formaldehyde in them as well, which is also a toxic chemical. So it's a solution that we really should scale. And, I think Kate and I have had these conversations of, being in this position where you really started out as an artist and you've ended up with something that is looking very different to that. But we both kind of feel like we have this opportunity to really affect some big change. So part of that needs to be about scaling. And there are huge challenges. I mean, the cost of bringing in something completely new means that you really bear those barriers to entry that are for the first time. You're the one that has to work out how it works. And what is important to me, and also what is like a big thing to sort out and find a solution for, is that way to scale with circular. Because I think that's where we've gone wrong. You and I were talking about this earlier. We were saying, plastic is an incredible material. It's why it's so widespread everywhere, but it's being used in this way that doesn't recognize how valuable it is and how really finite it is. Those raw materials are not existing forever. They take millions of years to make, and we've used like almost all of them in like 200 years. So we need to start thinking about how to build that circularity in. It should have been built in from the beginning with petrochemicals. We've ended up with the way that recycling is kind of trying to be run at the moment is more carbon intensive than making new plastic. All of our plastics are there's so many different types, and that makes the whole recycling process very expensive because it's labor intensive. And, at the moment in Australia, our recycling is shipped all over the world. It was shipped to China for a long time. In 2020, China stopped accepting it. Now it's sent to Indonesia, and that's ridiculous. Like, to have your rubbish being shipped across the world is nuts. So I think what really needs to be done is we need to think about how to scale in a way that we can have a circular, decentralized kind of local way of recycling this material. And so another thing we were talking about earlier is like how to manage investment. And, I'm very much like, I think this needs to be slower. The way that startup culture tends to work is to move at really quick pace. And I think what gets left there is also when you have investment, you then are beholden to creating a profit in a certain amount of time. And what gets left off there is the things that are most expensive. And R&D and working out a brand new system for recycling, and also something that's usually labor intensive, is going to get cut. So the way that I want to do it is to do it slowly and to work out a way that it can be financially, a system that works, because it needs to work financially as well. Otherwise, people won't do it. So that's the next solution. It's gone from making a material to like making a business system work, really.
So a slow and circular model of scaling up is what you're suggesting. Kate, what's your insight from your experience?
Yeah, look, it's complex. It's I think we've got to look very starkly at our production and consumption patterns and behaviours. I think scale and the kind of the ferocity at which we expect to scale and scale rapidly, and particularly, that is, just like Jessie was saying, really attached to startup culture. It's kind of language that gets embedded and co-opted into, conversations around the bioeconomy and seaweed saving the world and these kind of throwaway lines. It's often with this assumption that we can just drop in and replace existing products. And I think a huge part of our issue is not having enough conscious consumption and a conscious understanding of the amount of energy that goes into making things. Once we've made things, what actually happens to them when we decide that they've spent their life, we've broken them, we don't use them anymore. So, yeah, how are we kind of scale is a really tricky one, and scale's a really tricky one when you talk about bringing in green building materials or low embodied carbon building materials, because of the scale at which the building and construction industry exists at. So there are such incredibly huge problems in that space. The emissions alone from building products and materials in Australia are just absolutely outrageous. And there is, rapidly increasing rules and legislations that are going to require developers to commit to working within very strict embodied carbon parameters. But I think part of our work as artists, as designers who are kind of working in this new material space, who are kind of trying to go down this line of then seeing what is maybe, or what started as a artistic inquiry and as a creative inquiry, and following that through to a real world application or outcome, is about also trying to change the conversation that we're having about those materials. So how long they last, how they weather, what our relationship are to them. I don't think we can expect green building materials to perform in the same way that steel does, that cement does, that glass does. But there are other attributes that we can explore that those materials can have. And that's sort of one of our roles, I think, is to help people to understand what it is to encounter and to inhabit those kind of spaces and those kind of materials.
Yeah, and the benefits that these architectures can bring. I was talking with the participants here at the Jan van Eyck about how clay or soil architecture are actually these very healthy spaces in which to live, rather than living in concrete architecture. But there is another very, I think, important dimension of your work that it's actually crossing your work both. How indeed you both started, and you're both currently having an artistic practice, but at the same time, carrying on this artistic practice led you to feel this sort of almost ethical responsibility about engaging with questions such as scaling up. So starting, indeed, you both have also a design practice. So I wonder, within the sphere, your personal sphere of artist and designer, how the coexistence of a design studios and an interdisciplinary universe, practice within the academia, are helping, supporting perhaps your artistic practice, or perhaps asking for compromises. So how are they, creating spaces or taking perhaps space to what is normally called artistic or design freedom, right? We start with Jessie.
Yeah,
go for it.
I guess, one thing is that I have been hand making the material that I make, and as that demand for the, decals product has grown, that handmade process is very much using my time, and so it's diverted my time away from artistic production. Although I still have managed to do quite a bit of that, but it's just been long hours. So the other thing is, it's not been very, I've spent about 5 years kind of learning how to make this, and so like you were mentioning at the start, there is tacit embodied knowledge that is not easy. I can't kind of tap someone on the shoulder and, find someone that can come in and help me immediately. It would take quite a while for me to teach someone, and I don't really have that time. So it's this catch-22 where I just have to do it. The next step for me with scaling will be having, I've been working with producers of traditional vinyl, boom studios, to help me kind of work out how to machine the material that I make. And so they're going to start producing for me. We'll have, a partnership to then go on to scale the decals. And that will give me some time back eventually. But, also I think it's this economic discussion. It's kind of come back to this system of if you want to practice as an artist and you don't want to be beholden to, spending your time working in another job to finance that, or making kind of commercial work that is going to provide you an income, you need to do something in order to enable the sustainability of your artistic practice, because it's very hard to maintain that on its own. So I think this is also providing a source of an economic means for me to finish, doing my artistic work, but also because my work is so rooted in this material process, answering questions that allow me to produce things in my artistic practice. Usually that's by doing research that is often very expensive. And so having this other side to it allows some of that to be kind of offloaded into this kind of commercial sphere, and also brings on, partners. The Metropolitan Museum of Art in New York is interested in using the decals, so they've taken it upon themselves to do some research for me that I would have done, if they hadn't done it. So it's given me access to collaborators that have really helped, and the practices are kind of intertwined in the way that they're both rooted in the same material knowledge and work. So one will help the other.
Yeah. Kate, how do you experience the tension between the different practices?
Yeah, as an artist, as an academic, as a materials researcher, it all feeds each other in ways that sit in tension, but also sit in incredible kind of incredibly complementary to each other. I think what I've learned through 15 years of art practice and 15 years of handling materials is a kind of that tacit and embodied knowledge, and the sort of those the way in which you accumulate knowledge through your hands. That is something that that always comes with me through every material investigation. And I think what has opened up for me in terms of being an academic and being a researcher is the possibilities of going beyond the edges and boundaries of my disciplines and into others through collaboration. So it's only through these networks that bring together design, science, polymer chemistry, algal biotech, creative practice, artistic inquiry. It's only through that we've kind of been able to get to a place where we have these kind of real world new material possibilities. That's not a kind of soul endeavour space, and I think that has always kind of been what's excited me most about making, and what's driven my curiosity is the ways in which you can kind of bring together other knowledge systems and graft them onto each other and entwine them and learn from them. And it's through those kind of encounters that we've been able to arrive at the types of potential new material realities that some of the seaweed and oyster work that we've developed is offering.
I think we were also saying before that we were now at this time in history, it feels like it might be a tricky time to just be making artwork about this stuff. We're at this quite urgent stage where we're both feeling this pull to really do something as well, like stepping outside of the gallery, into this world that needs change.
Yeah, I think there's so many ways that art can be in service of other things, and I think that's a really exciting and challenging landscape to navigate. Is how do you take what you have garnered through practice and through creative inquiry and fold that into other spaces that traditionally or conventionally don't necessarily have that. What happens when you embed design at the outset of materials innovation? I think you get other types of material realities start to emerge.
Yeah, and I think you're touching a very important point. If we think about knowledge and about transition, in the current times, how we should bring the arts up to speed, meaning being recognized and legitimized as the sciences or other disciplines that have been seen very important, but how the arts can contribute also with its autonomy and freedom, but also to bring this perhaps also affective, emotional, embodied relation with the landscape that cannot be grasped by social sciences, even anthropology, but also the hard sciences, perhaps. Perhaps staying with this emotional, affective dimension of our practices, I will end with a more romantic utopian questions. And I would be very curious to hear from you. How do you think that your materials might change the world?
Well, I mean, I think there's that immediate thing of if we look at what I'm looking at with the decals at the moment, I mean, we can find a signage replacement, and really when it's a sticker. Stickers are everywhere. But I think what also happens there is, I am not a scientist. I don't have a crazy lab. I've done this on my own in a couple of years without any kind of specific help or huge team. So I think it's also about, showing people that it can be done and that, there's some hope there that we can change the way we're doing things. And also to prompt other people to start making changes, and also, people won't look at materials the same way. Once you start inspecting, it might start from thinking about this decals conversation, but, you cannot cast your eye around the room and not see a petrochemical and think about the impacts that is having maybe on your health right now as you're breathing, maybe on the communities where it was produced, maybe on the, ecosystems and communities where it will end up. So I think, all of that, more consideration.
I think we have the opportunity and the possibility to build differently and to think about, inhabiting spaces and structures that are living, that are different in their kind of patina, in their being, in their coloration, in the way in which they weather. I think we also need to be thinking about how materials can draw down and sink carbon dioxide. That's something so important that we need to do. So how we can lock CO2 into materials and put those materials into places for a long period of time. And seaweeds and algae present a really, really exciting opportunity to explore that. And I think where and how it can be connected into what are really rapidly expanding areas of the bioeconomy and the biotechnologies that are able to grow and produce a large volume of biomass, and where that biomass comes from and through a biorefinery framework like we talked about before, that is a really exciting opportunity. And that is, I think, how we can start to think about conceiving of new types of building materials and products.
Thank you. Jessie, Kate, I would like to thank you so much. It's been a real pleasure to share also some questions that we have here at Future Materials with two such inspiring artists, designers, researchers, and so much more from a very far away geography. So thank you very much.
Thank you.
Julia.
Thank you.